Hello, everyone. So today we're going to be talking about another fundamental concept of organic chemistry, which are identifying functional groups. So you have to be aware of these functional groups. So I've noted down the most common functional groups that you would need to know at least your first semester of organic chemistry. And then as you progress, you're going to have to know some more functional groups, and we'll tackle those later. So let's go over some of these most common functional groups. So I've broken them down into what elements are involved in each of these functional groups. So the ones on the left, we have the ones that are only constituted with carbons. In the middle, we have carbon and oxygen. And on the right here, we have ones with carbon and nitrogen, as well as one with also having carbon, oxygen, and nitrogen. All right, so let's start off with the ones that have only carbons. So firstly, one of the ones is, so firstly, the most simple one is an alkane. An alkane is simply having a carbon-carbon single bond. So whenever there's a single bond between two carbons, we call that an alkane. So you could have a chain where you have a chain of carbons having single bonds with each other, and that would be called an alkane. An alkene, on the other hand, is a carbon-carbon double bond. Okay, so whenever there's a double bond between two carbons, we call that an alkene. So alkenes generally you would see within a long chain of carbons, you might have one or more alkenes. And then an alkyne, on the other hand, is whenever you have a carbon-carbon triple bond. Okay. So carbon-carbon single bond is an alkane, double bond is an alkene, and triple bond is an alkyne. The other thing that you should notice is that the alk part is the same in all these three names. The only ones is the change in this letter right here. Okay? So it's the AEY. That's the only thing that you should be aware of. So when you whenever we talk about IUPAC naming, which is another concept that you need to know, in organic chemistry, which is just naming different compounds, just the A, E, and Y. So the ane, ene versus ine is what distinguishes between carbon-carbon single bond, double bond, and a triple bond. All right, so next we have functional groups that are constituted between carbon and oxygen. So the first, most important one is alcohol. So alcohol is whenever you have a carbon single bonded to an OH group, right, or a hydroxide group. So whenever you have a carbon bonded to an OH group, we call that an alcohol. Okay, a ketone is whenever you have a carbon that is double bonded to an oxygen, and then that carbon specifically also has to be bonded. Its other two bonds also have to be to other carbons. Okay, so that's the only time we can call that a ketone. So a carbon that is double bonded to an oxygen, and that carbon also has its other two bonds also are to carbons. An aldehyde is actually very, very similar to a ketone. An aldehyde also has a carbon which is double bonded to an oxygen. However, with an aldehyde, it doesn't have to be out of its two bonds, at least one of those bonds has to be to a hydrogen. So the other bond could also be to a hydrogen or to a carbon, but at least one of those bonds has to be to a hydrogen. So that's where the hyde comes from, because it's referring to the hydrogen. All right, so aldehyde. Another thing that you should be aware of is that this group right here, whenever we have a carbon double bonded to oxygen, that group right there also has a common name, and that common name is called, so we also refer to that common name as a carbonyl. Okay, so you will also hear the term carbonyl. So a carbonyl just refers to a carbon double bonded to an oxygen. However, with a carbonyl, you can either have a ketone if that carbon that it's double bonded to is bonded to two other carbons, or if it's bonded to at least one hydrogen, then it would be an aldehyde. Okay, so next we have an ether. So an ether is whenever you have, essentially you have an oxygen that's sandwiched between two carbons. So it's an oxygen that's bonded to two carbons. All right, so an oxygen surrounded by carbons on either side, but single bonded to carbons on either side, we refer to that as an ether. An ester is sort of like an extension of an ether. So in an ester, what you will see is an ester has this carbonyl group, which is a carbon double bonded to an oxygen, okay? But it also has an ether group on it, okay? So it has this oxygen that is sandwiched between two carbons, but then one of those carbons also has a double bond to an oxygen. So a carbonyl, so when you combine a carbonyl and an ether group, these two together is what give you an ester. Okay? So carbonyl and an ether combined give you an ester. And then lastly, we have a carboxylic acid. So carboxylic acid is also actually a combination of two different functional groups. So in a carboxylic acid, you have a carbonyl group as well as an alcohol. Okay, so whenever you have a carbonyl group and an alcohol, those two combined together give you a carboxylic acid. So whenever you have this carbonyl that combines with an alcohol right here, them two combined give you a carboxylic acid. Okay? And then next we have functional groups that are made up of carbons and nitrogens. So an amine is whenever you have a carbon that is single bonded to a nitrogen. So generally the nitrogen would also have two hydrogens on it, but it might have other carbons. But that right there is referred to as an amine. So a carbon single bonded to a nitrogen, we call that an amine. An amide is another group that is a combination of two groups. So an amide also has a carbon single bonded to a nitrogen. However, what it has in addition is that it also has a carbonyl group. Okay? So an amide is a carbonyl group and an amine all on the same carbon. And whenever that happens, we call that an amide. All right, so I hope that was helpful. So again, if you have any questions, leave them down in the comments. I'm also going to leave behind my email in the description. So if you have any questions, you can email me on my email as well. Thank you.